Good afternoon, everyone. Oh, that was pretty loud. Guys, so today we are meeting again in the next session of our Autonaut Assemble and carrying on as we said that we'll do it every week. ज़्यादा loud then? It's too loud. So today we gonna discuss सबके clear थी? हाँ. Okay. So today we're gonna be doing a session on the MongoDB. So we have been using the NoSQL database. Some of you directly using it. Some of you must be have used it in your previous experiences, or some want to learn and use it. So we have today team from the MongoDB. So we have Nitin, who is an architect with the MongoDB and has an extensive career dealing with the databases and the NoSQL databases. Along with him, I have Aryan, who is the customer service management team with the MongoDB and closely working with us. So the intent of this session is to learn the MongoDB. For some, we'll start with the basics, but we will go into the deep dive into the various different advanced aspects of the MongoDB. And this is our chance to learn it directly from the team who is building it, who is working on it. So I will request all of you to just please devote this 2.5 hours to your learning. Shut down your laptops or close the lids and just pay attention. Thank you. Over to you, Nitin.
Thank you. Thank you so much, Deepak, for introducing us as well as inviting us for this, event, right? It's a great opportunity for MongoDB also to enable Cars 24 team. And frankly speaking, I see a lot of people joining here for enablement. Mostly, we don't see this much people during the MongoDB events also, right? So that's a good platform for us also. So I'll just start with introduction to MongoDB, the account team that you have, the Cars 24 team has from MongoDB, and then we will deep dive into the technical stuff, right? So this is going to be the agenda for today. So as you see, we will go into the basics, then we will go to some, deep concepts also. We'll talk about MongoDB Atlas, which is a managed offering from MongoDB, and Cars 24 is currently using it. But we are here to provide some of the best practices for the Atlas so that you can deploy your clusters in a more optimized manner. This is the accounting that you have for Cars 24 from the MongoDB team, right? So today, me and Aryan are there. Aryan is the customer success manager. So any challenges, anything related to any your deployments, and for any technical related things, if you are launching new application, if you are evaluating anything, if you are facing technical challenges, I am the spot for the Cars 24 team. But you also have many other key folks from the MongoDB team assisting the overall Cars 24. Right now, before we go, right, I just want to start with a fun trivia. So let's see, do you know what the world's most expensive car? Without Googling, of course, right? Anyone wants to give it a guess? Okay, so it's Rolls-Royce. Of course, the top 5 cars would be the Rolls-Royce only, but Rolls-Royce LaRose is the most expensive car as of today, right? Any idea of what it would be costing? No, what would it cost you if you want to buy this car? A rough guess.
Crores.
Yeah,
Around
lot more crores, right? It's two. Yeah.
yeah.
So it's a very expensive car, right? So that's why we are here to also talk about optimization so that your Atlas bill does not go somewhere near that, right? That's also the key idea. Okay, now beginning into the introduction of MongoDB, right? So as you can see, we started as a company in 2009, and At that time, apart from MongoDB, there were many SQL databases which started in 2009 itself, right? So if I have to out of Cassandra is there, there are other NoSQL databases are there. But if you see the growth that MongoDB has seen since in that 10, 15 years of time, we now have more than 42 million downloads for MongoDB. Customers who are using MongoDB, whether it's the paid version or the open source version, but we have so many customers using MongoDB, right? 9,000 paid customers at this moment. This is a big number in this industry. And more importantly, if you see on the right side, the bottom right side, on the Stack Overflow, which is actually, this survey was done by 70,000 developers on Stack Overflow. From last 4 years, MongoDB has been rated as the most loved database. And today we're here to explore why is that? Why is being MongoDB voted? What are the features that enable developers to build their application seamlessly? And how you can, basically utilize those features to build your applications. Right? Now, that is where comes the comparison with the relational databases. Now, if you see on the left side, you see the expressive query language, asset transactions, enterprise security. These are the features you also get with relational databases, the likes of Oracle, the likes of Postgres, SQL Server, right? But what Mongo brings on top of it, apart from these features, so we are not compromising on these features, but we are also providing you scalable and distributed architecture through sharding, horizontal scaling. We are also providing you, so if I have to give a very basic example, right? So if you are deploying Postgres in your current or MySQL in your laptop, and then you go to AWS, you would have to choose AWS RDS, which the software is different. If you go to GCP, it is some other flavor of MySQL. But for MongoDB, whether you deploy on your laptop, whether you deploy on EC2 instance, whether you deploy on a managed service, the software remains the same. No code changes, nothing. So that's one of the key reasons developers love MongoDB, because they do not have to change their application whenever they are using it, right? That's so in short, the purpose of this slide is to tell you that you are getting the same features as your relational database, but on top of that, you are getting new features which are being provided by many of the niche databases. And this is how, as an organization, we have grown our product over the years. So in last 5 years, MongoDB has spent over $1.5 billion on R&D. And that R&D has resulted into these many features across different versions. Every year you will see a new version coming into existence, and with that, lot of new features. So we recently launched version 8, and that is the fastest MongoDB version ever. We are claiming that if you were running your workload on version 7 or before, or 8 or before, just upgrading to version 8, you will see at least 20 to 30 performance increase, or even if you will be able to go to a lower tier, less resources, saving your cost. So that's we have spent so much time in engineering in terms of giving you more performance. On top of that, there are a lot of features. For example, you could do GenAI applications, you could do vector searches, multi-region clusters, many things. I don't want to go in detail because the feature is huge, but I just want to showcase that as an organization, we put lot of effort into R&D. And today, if you say that one feature is missing in MongoDB, within few quarters, you will see that feature based on your requirement being built into the product itself. That's how we are working closely with the customers and bringing new and new features fast. Now, right, so before we go into the details of why customers love MongoDB or how can you use it into better way, right? I just want to give an analogy here. The analogy is that just like Cars24 is simplifying the car resale, right? Similarly, MongoDB is simplifying your data model or how simply you can handle the data. Even if it is huge data. The Mongo name itself came from humongous, right? So it is meant for handling huge amounts of data. Now, these are the three critical pillars that we will be talking about today. One of the pillars is the document model. MongoDB, unlike relational model where data is stored in rows and columns, rigid schema, MongoDB is a document model. Document model is nothing. It's the JSON data. So the way you see JSON data, that's what document model is, right? And we will deep dive into that. Secondly, we our cloud offering, which is MongoDB Atlas. You can deploy clusters spanning across GCP, AWS, as well as Azure. A single cluster can have nodes across all three clusters. Or if you want to move from AWS to GCP or vice versa, without any downtime, with just one click, you can actually switch from one cloud provider to another. So we are providing a lot of flexibility in terms of how you deploy your clusters. And finally, we will also talk about data platform features, which are very interesting, right? So we will go into detail into those, but that brings a lot of productivity to you as the developers. So now let's deep dive into each of the pillars. The first pillar is the document model, right? Which is the basic for MongoDB. So for folks who are starting new on MongoDB or have basic knowledge, this is what will build your base towards the MongoDB, right? Let's see the document model in action. Now, this is the comparison of MongoDB with relational databases. This comparison is put because many of you might have worked with relational databases. So drawing one comparison gives you a mental map how it would look like. So if you see, we have databases, tables are called collections, then row is called a document here, column is called a field. Last 3 points are important because that is a misconception with a lot of customers also. So MongoDB does support joins. You can join data across different tables or collections. MongoDB does support ACID transactions. There is a common misconception that NoSQL databases cannot do ACID transactions. But we at MongoDB claim we are not a NoSQL database, we are a general purpose database. And we can do multi-document ACID transactions. In fact, as we speak today, in India, one of the large bank is building their core banking application on MongoDB. So you can imagine the kind of transactions or consistency they might be requiring. So they would be having their complete core banking system on MongoDB. And if there are questions, right, feel free to interrupt me in between. You can take those questions in between. That's completely fine. Now, the next question is why document model? So before we even go to Mongo, right, why document model? So key thing is that document model can be modeled in form. So document model can be modeled into your relational structure like tabular. It could be molded into key value form or text or geospatial, even graph and time series. So the basis of modern applications, that why is the document model. And that is where, if you see, right, once MongoDB came into existence as a document model database, although AWS has many databases, they still created a service called DocumentDB, which is nothing but using MongoDB API on top of Postgres. Azure created a service like Cosmos DB, which is nothing but an MongoDB API on top of relational database. Why did they do that? They did that because document model is so famous among the developers. It is so easy to launch your applications or build your applications using document model. That's why they are imitating MongoDB, right? So that's the popularity MongoDB has gained, that the cloud providers are starting to imitate what MongoDB is doing by building their services, which is nothing but an API on top of relational databases, right? So the key thing is now, just to give you a context into things, banking systems having their document into storing data into key value stores have now mandated across world that banking transactions would be in JSON format. So JSON has become the go-to standard for any banking transactions. Similarly, you will see in other industries also JSON or documents becoming very popular, and that is why document databases are getting a lot of popularity. Right now, coming to MongoDB here, right? Now, here is in comparison with the relational databases and the document model. If you see on the left side, you will see customer information spread across 7 tables. So because usually what we do a lot of normalization in relational databases. So we store customer information. If I need to store the customer preferences, the customer, which country he lives in, which city. So the tendency is to normalize the data across multiple tables. And while I'm fetching the data, what I will do joins across multiple tables, right? Now, firstly, we need to understand why we used to do that. The main reason we used to do that, so the relational databases came into existence in 1970s, right? At that time, storage was very, very expensive. So duplicating data was not the choice. So what we used to do to avoid duplication, we used to normalize the data so that there is no duplication at all. But here, if you see today, storage is very cheap, right? I am having a mobile with 256 GB storage, right? Or even more also, even 1 TB storage you can have on mobile. At that time, that was not possible. So even if I am duplicating my data, let's say my data size was 1 TB, after doing some duplication, it is increased from 1 TB to 1.1 TB. That is not going to cost me much. What is going to cost me if my RAM increases from 64 GB to 128 GB? That is going to cost me a huge amount of money. That is why in document model, if you see, all the information that I was storing across 7 tables, now I am being able to store in one table or one. So what happens is, if you see the details of the customer without doing join, with a single fetch, I can get all the details of the customer without performing any joins. No joins means no CPU cycles being utilized or less CPU cycles utilized. And basically, I'm saving a lot of resources on the system, or I am able to perform the same query with much less resources. So that's the benefit of the document model. Again, the thing is that you do not want to denormalize everything, but main concept, and we will come to the data modeling piece, but the main concept in MongoDB is the things that you want to store together should be, so the things that you want to access together should be stored together. That's the key concept. So if you think, let's say you are building some application for Cars 24, and imagine you have a page, whatever things you want to showcase in that page to the customer, ideally they should be stored together, wherever possible. So if that is the case, that will be a single fetch from the database, and that page would be loaded, and it would be much efficient than having data across 5-6 tables. And for that page, you are doing joins on the runtime and then loading that page. Because you can do that in MongoDB or document model, that's why you can. And why you can do that? Because it provides you rich data structure. You can have arrays, you can have sub-documents, you can store geolocation inside the same document. In fact, for the same field, you can have different data types across the different tables also. We'll come to that piece also. But understanding this slide is very important, because that is the core of MongoDB. That we do not need to analyze, because storage is not that costly now compared to what it was earlier. And once we do denormalization based on our usage, we are not saying denormalize everything, but whatever you want to access together, if you are storing together, then you save a lot of cost, because you are using less resources for that, right? So that is the key thing for the document model. Taking this further, now I was talking to one of the customers, and they were using MySQL, right? Their main challenge was that they are competing with startups in the banking industry. And what I'm talking about is a huge bank in India. They are competing with startups who are banks, small banks, SMBs, right? Where the small banks are able to launch new features in their application every week, sometimes twice, thrice within a week. But that bank is not able to do so because every time they have to launch new feature, they need to do a complete change management life cycle, and it takes them 3 months to launch any small feature also, right? Why they are not able to do that? That is what the crux of this slide is. So if you see in a document model or on MongoDB, if your schema changes, you can do that in fly. So for example, let's say I'm storing customer information. This information is, let's say, from 10 years back. At that time, maybe customer was having only home phone number or mobile phone number. Today, he wanted to add maybe his Twitter ID, his LinkedIn ID as his contact information. Or in this case, just the phone number needs to be added. Right? This can be done without going through any downtime in the new document or a new version of the document without any downtime. So if you imagine doing this in relational word, adding a new field, you need to add a new field. You need to fill previous documents with that field, some value of that. You don't need to do that in MongoDB. Of course, you need to fill that with the values, but that will not take any downtime. You can simply add a field here, version 1 and version 2, where version 2 of the same document would have phone number and version 1 would not have. And gradually you can migrate all the documents from version 1 to version 2, but not having downtime. So able to launch or ship new features as frequently as you want to without going any downtime, because the documents are flexible to change. They adapt to change. You can add fields on the fly without undergoing any downtime. That is again very key point with respect to MongoDB, right? So if you are building applications using relational databases, facing such challenges, try MongoDB in such cases, and you will see that without these challenges, you would be able to iterate through your application. So this is the second point. So this is again from a customer perspective, and this is not something which was given in positive to MongoDB. This was the customer was basically making fun of MongoDB, right? So what they mentioned is that MongoDB is so flexible schema that it can do yoga better than me, right? So we felt that okay, they're praising the MongoDB flexible schema, but their point was that sometimes what happens that their customer or they get CSV files and they load it directly to Mongo, and those CSV files sometimes would have 10 columns, sometimes would have 20 columns, and you get garbage data into my collection. So my collection does not have fixed schema because you are providing flexibility, so I get a lot of garbage data, right? But the point is that you do get flexible schema. You do get ability to change your schema, iterate your schema. But you also can control that, which is the main thing. So let's say you have a use case. You have two use cases in your application. In use case 1, you want to have a flexible schema, which we talked about. So a possibility, you have a use case where you want strict schema, rigid schema like you do have in relational databases. That is where the data governance comes into picture. You can define data governance rules saying that these fields must be present. So for example, in this case, I have provided required fields, name, major, GPA address. These fields should be present. If these fields are not present, my document would be rejected or it would be a warning would be, sent to the application so that I know something has happened here. So, and I can also say, okay, these fields should be there, but some of these fields should have either a string data type or integer data type. And then I can also say that apart from the data type, if I want to define a value also, so maybe a value should be between 1 to 100. then only it will be accepted inside the database. Basically, I'm defining data validation rules on the database side so that I do not get garbage data inside my database, right? You can have fixed schema, and then you can also have flexible schema that we talked about this slide. So you will hear me saying that flexibility is there. So we are providing flexibility either to have a flexible schema or a rigid schema based on your application requirement. So again, three key things that we discussed was the document in terms of we do not do visualization. We want to things to store together whatever we are accessing together. Secondly is flexibility of the data model, and because we can add the fields, delete the fields, and finally the data governance. These are the three key things with respect to document model and MongoDB that we provide that enable developers, or that is one of the reasons why MongoDB has been named most loved database, on Stack Overflow. Now, another thing is that, okay, you might say that, and I have been working on relational databases I have worked for 10, 11 years before I switched to Mongo, right? So now the main is how do I move to Mongo, or how do I learn? What is the learning path going to be? Maybe you could say that all my life I have been relational and I know Python or I know Java or I just know one of the language. So what we have done is, within these drivers or within these languages, if you know any of these languages, you already know how to write queries or how to do insert updates inside MongoDB. But we have created functions inside these drivers to basically look up operations with or interact, how you interact with the MongoDB. So that's again, we are making things intuitive for the developers so that the learning path is not that big. Of course, there is going to be learning path moving from relational, but the learning path is going to be very easy because if you know any of these languages, you already know how to interact with MongoDB. That's again one of the key things that MongoDB is being adopted widely. And this is again an example, right? So if you see, going back to having 7, 8 tables versus a single table, if let's say you want to do an insert, and this is a live code sample with one of the migrations, right? So if you are doing in any relational database, you are doing inserts, because your data is spread across multiple tables, you need to take into account those, and a simple insert could be so much line of codes. Whereas if of course your data is stored inside a single collection because of rich data structure, because of arrays, sub arrays, at the between that you see, at the middle you see, the line of code is what we require, right? So this is again a key advantage that you will see that over of lines of codes, application code would reduce drastically for most of the applications because of the ease of the data model. This is again one of the key things that is there. The overall application code would reduce when you are moving to document model, specifically MongoDB. Now, one is able to store the data, right? And now we might also say that MongoDB is not just the only document data. There are many other document databases also. What value does MongoDB brings? Like data governance was one thing, but what value MongoDB as a database brings, right? So if you have your applications, so what can you do with that? So querying data is also very important. And where we that one thing which was very good in relational databases is they provided very good querying and indexing capabilities. So our idea was we would not compromise on those capabilities apart from what we are building in Mongo. So many NoSQL database, you will see what would happen is that they might be able to create index only on the partition key, not the secondary indexes. Or there would be very limitations when you are querying with the secondary indexes. But here on MongoDB, you can see we provide different kinds of queries, and we will go into examples of some of these queries. So you can do expressive queries. For example, in this document, if you want to see, give me document first name is this, phone number is work, and maybe city is something. So if you want to do an expressive query which would span across multiple fields, do filtering, do sorting, do grouping, that can be easily done. Not just expressive. If you are doing geospatial queries, from this point give me restaurants nearby. So Zomato uses MongoDB for their driver application. So if you are ordering any food through Zomato, basically you are using MongoDB at the backend, right? So you can imagine the scale at which Zomato is working, and they are using geospatial queries at a large scale. Then we do joins also. If you have any graph databases, we do provide you graph lookup capabilities also, which is similar to traversing graph in the graph databases. And one important thing that you see in between is aggregation. So aggregation is how we run complex queries inside MongoDB, right? So we'll talk about aggregation, and then we will go into few examples, right? So I think a lot of slides, but we'll go into few examples after a couple of more slides, right? So what is the aggregation framework? So one way is you write simple queries. Aggregation framework is if you want to transform your data, if you want to do complex queries inside your data, that is where aggregation frameworks comes into picture, right? So if I have to talk about the aggregation framework, what happens is there are different stages in aggregation. For example, dollar match. Dollar match, you can imagine, give select star from something where. Whatever I put in the where clause is dollar match. So if I say match me all the documents, so all those documents will be passed to the next stage. Then I am doing a lookup. Lookup is nothing but the joins and the proceeding stages. But the idea is that you can see in every stage, you are reducing the number of documents that are being passed, which provides you efficiency and structuring your query. If you want to think of joins, people who have worked on Linux, Unix, right? So we provide something called pipe. For example, PS hyphen, and then we provide pipe, before grep Python. So pipe is something which is separating one command from another. Similarly, these aggregation frameworks, you can think of these pipe as the different stages. Now, why these stages? There are different ways of running queries. You are writing complex queries in SQL also. So if you see this example, a SQL query that you have, right? So basically, I'm trying to get the bios with books that have average 5-star rating. So SQL query would look like this. So I will do join across different tables, and this is obviously there are two tables involved here, but it could be multiple tables and it could become very complex. But here, if you see that query being converted into the aggregation pipeline inside MongoDB, what would happen is now I am able to break the bigger query into smaller query or stages, which helps me build these queries in an efficient way. So I'm doing dollar group. So in my mind, if I'm thinking, okay, first I need to group the documents. Okay, I'm grouping the documents. Now I need to match the documents, filter out the document. So I am filtering that average rating is 5. So all those documents where average rating is 5 are being filtered out. Only with 5 would be going to the next stage. And similarly, I'm doing the other stages also. So building the query becomes very efficient using these different stages, which are the building blocks of the query. So you are basically, if you have a very large query, you break it down into smaller segments, and that segments are basically the stages of your aggregation pipeline. Right? Now, I think we will see some of the examples for which I need to connect my laptop. Okay, here it is. Okay, so let's see few of the examples, right? So Firstly, we will see the example. Okay, let's see some. So first, let's understand the data that we have. I will maybe make it big if I am able to. Is it visible? Sorry? Yeah, that's what I'm trying to do. Better? Okay. Yeah. So basically, I have a customers table here or a customers collection here with this data. So I have different fields here, region, last name, different things. Then I have address. And address, as you can see, is a sub document. And I have then policies here. Policy is an array. Inside the policies, you can see that there are different kind of policy. That I have policy type auto, then I have policy type life. It's a life insurance policy. And then I also have home policy, also maybe a home insurance policy. So this is the document that I have, one of the document that I have inside MongoDB. Now, in terms of looking at the querying capabilities for MongoDB, if I want to look in that, right? So let's take few example. I have few queries here. So firstly, let's say a very simple query that I want to see is find me all the policies where the policy type is auto, right? Now, before I go into that, let's first understand that I want to do. I am saying that I have an array. Inside the array, I have an field, and I am going to access that specific. I am able to. I want to query on that field inside the array. Right? It's not a simple field query. It's an query on the array field. So what I am saying is that give me all the policies where type is auto. Right? So it's a straightforward query because I can use my dot notation here. Give me documents where policy type is auto. It's a very simple query. But to showcase you that, yes, of course, within the array, you can run these queries. That's a very basic example. Now, let's say I want to run a query, which is, let's say, a bit, complex query at this time. Okay. So in this case, I am saying give me the documents where gender is female, okay, one filtering, where date of birth is greater than this and less than this, next level of filtering. Now I am saying where state is UT, another filtering. Here I am doing filtering inside the array or sub document in this case. And then I am looking for policy type as life, and under policy type, I also have insured person smoking true. So that means I want to know the males within a certain date of birth who live in UT and have a life insurance and do smoke, right? So you can imagine it's a very complex query. If you start thinking, if you want to write this kind of query inside a relational database, first of all, your address would be in a separate collection or a separate table. Your policies would be in a different table. Then you would have separate table for separate policies. For life policy, you would have a separate table because every kind of policy would have different kinds of fields, right? So you would need to store them in different tables. So basically, we are talking about joining across 5, 6 table and then fetching this data across multiple there. So it is going to be very complex query inside SQL versus here it's very easy. Now I want to know, does anyone know what this LM match means? So many of you might be using MongoDB already, right? Why do I need to use LM match here? Why can't I simply run the simple query dot notation query? Anyone? So how should I do it today? Okay. So any guess why do we need LM match? Why can't I simply do the dot notation? Absolutely, right? So we want to filter out within the array, right? So within array, what would have, I would have, I can have policy type or insured person dot smoking. There might be multiple with life and the in short person smoking, yes or no. So I want to traverse across the arrays. So if you want to traverse across the arrays, we need to have an operator which is lm match. You can do that way also, but lm match is an efficient way of traversing across the arrays, right? So just remember, because to utilize the rich data structure, you need to have arrays, and if you are having arrays, just remember you would have an match there, right? So that's one of the examples with respect to queries, right? Now, coming to the aggregation pipeline. Now let's come to the aggregation pipeline. Now this time, this is an example or data from a banking customer. So these are the bank account details. So a customer is having a current account here, and then they have savings account, and then they have mortgage account. Different kinds of accounts are there for a single customer. Again, if I think here, if you would have stored this in relational databases, you would have a customer table, then you would have current account table, saving account, and mortgage account table. You would have four tables in this case. But in this case, since I as a customer, when I log into that, maybe I am using, ABC Bank. If I log in into that bank, if I want to see what are all the kinds of accounts that I have, it should be given mostly on a single page. It should not be that first I click, I go to the current account page, and then at least it should list all the kinds of accounts. So it makes sense for me to store them together. Again, remember, things that should be accessed together should be stored together. That's what I'm doing here. So here I am storing the current account, savings, and mortgage for this particular customer together itself. That's what I am doing here, right? Now, in this case, let's see that how we can run complex queries, or what we call as aggregation pipeline, to derive value out of this data. So for that, we have something called aggregation pipeline builder. So which I was talking that. So let's say I want to do, maybe I want to see the average credit score of customers in England. So I will use that aggregation pipeline first. So I am here, I want to see that all the customers who live in England, what is the average customer credit score there, right? So the first thing is, I want to suit it for England customers. I'm saying dollar match where country is England. Basically, give me all the documents where country is England, right? Secondly, then I want to group the documents or the customers that have been given on the basis of country and giving the average rank, where I'm using the average operator, right? So getting the average rating or the average rank or the credit score in this case for all the customers, basically what I've done is I have changed my this query, which is the aggregation pipeline, into multiple stages, so that I can build this complex query, in this case not so complex query, into smaller stages, and it becomes efficient for you, right? One cool thing that has been done by our engineering team is, we have given you an option to export to language. If I click here, so if you are a Python developer, you can simply select Python, and it will give you the code in Python. You can include the inputs, and basically it gives you everything that you can directly put into your application. If let's say you are maybe a Java developer, if you click Java, it gives the code of this query in Java, so that you can simply copy this query in your Java code, and you can do that. If you are maybe C# developer, you can select C#, and it gives you that query code in C# also. So for you as a developer, building application in multiple languages, right? It becomes very efficient with this option of export to language. You just write the query using the aggregation pipeline builder through this, and whatever language you are writing your application, you can export to that language, copy the code, and simply paste it in your application, and it would work. Okay? So that's the benefit of export to language here. Any questions?
Navneet. So most of us, we don't really use Java as a core, right? We use a framework on top of it. Mostly we use Spring Boot, right? So do we also have an option to exporting into like Spring Boot like code?
No, currently only these language are being supported, but still it will give you a generic idea of how it would look like. So basically, if you are using Spring Boot, we are more or less talking about how it look like in Java form, right? So you will get an idea how it's good. See, this is mostly for developers who are getting started. Once you know a particular language for long, I don't think so people will use this. But when you are getting started, this turns out to be very helpful so that in your initial learning stages, these, builders help.
Okay.
Right. And then there's a few other, sorry.
So say for example, we are using this tool and there are like couple of stages, maybe 3 or 4 stages. So is this tool also helps to optimize, like say for example, stage one is should come to like on a stage two rather than stage one. So
Okay. So,
Amit, please come closer to mic.
okay.
So I was thinking of talking that thing later. This tool does not help to optimize, but recently we have integrated AI with this tool. So you see generate aggregation. So you can write your queries in natural language NLP and it will generate the aggregation pipeline for you, which would be an optimized aggregation pipeline. So maybe I'm not sure whether, so I need to log into Atlas for this, but once you log into Atlas, you should have an Atlas account, whether paid or unpaid, doesn't matter. You write your query in your NLP format, right, and it will generate the optimized query for you. This is something which you can do. But for this, you might need to use latest version of the Compass. That's something you need to be aware of. Right. And similarly, other aggregation pipeline also, for example, if we take a bit complex, so let's say I'm asking for what is the average credit score for customers across all banks operating territories sorted by the highest credit score. So increasing complexity a bit, couple of stages might get added here. So firstly, I'm doing the group stage, then I'm doing the sort stage. So sorting is again basically how you are sorting the data. You can build your queries, how complex it may be, how I've seen customers building with 20, 30 stages also. So, but again, the idea of today's interaction in terms of aggregation pipeline, two things. Firstly, if you want to run complex queries on MongoDB, you should use aggregation pipeline. Secondly, the another important thing is building the queries become easy because you can think of how the query will work and build stages accordingly. So you can break your larger query into smaller queries and those would be smaller stages in your application for the queries. Right. So that's what, basically about the, from the query perspective, these are few simple examples, but these are the building blocks of writing complex queries. Right. So also remember that, so it may seem that this query is very simple, right? So, you might think, what is he talking about? This is a very simple query and he's talking aggregation is a complex query pipeline. But why I'm saying so is this is possible because we are storing data inside a single document. If the data was stored across multiple tables, you would have seen at least a one-pager SQL query here instead of this small query. That is the key thing. Because of the document model, because of the rich data structure, it became very easy for me to do such complex queries also. That's the key concept. Right? So, yeah. Now, I'll just move forward for a few things because okay. Now, this is also, although this PPT would be shared with everyone, but this is also, this is a book that we have on Amazon. But if you scan this QR code, the book link, this MongoDB aggregation performance guideline book is freely available for the CARS 2014. Through this link or through this QR code, you can actually download this book and you can basically, learn about the aggregation pipelines. Now, you are able to query the data, right? So we saw that we are able to do complex queries just like we were able to do in relational databases, but they are of no use if you cannot do proper indexing. If indexing is not there, the query time, the response time would be high, and you would not be satisfied with that, right? That is why another key thing that we are providing on MongoDB is that we are providing you indexing capability as close as you get to relational databases. So the kind of indexing that you get in relational databases, most of those kind of indexes are available on MongoDB also, right? So that's another key point here. So you can see we can have compound indexes, multi-key indexes also. We also have a quiz in the end. So just some of the questions might be from this slide, but multi-key indexes are the indexes if you want to query arrays, just like we saw address.state or policy.policy type. So specifically inside array, if I want to do a query, basically I want to index only that field, not the entire array, right? So that I can do through multi-key index. And then we also have geospatial indexes. You can do 2D and 2D sphere indexes inside MongoDB. We provide you TTL indexes. So let's say if you want to basically delete the data automatically from the collection after a certain time, you can create a TTL indexes, and that index would make sure that data is deleted after the time you specify in the TTL definition, right? So if for a certain collection, the duration or the life cycle of the data is 6 months, while creating the index, you would say that after 6 months from the data insertion, delete this data. So this will do the TTL indexes would do that. Unique indexes, so multiple kind of indexes also there. We will talk in later stage, but I think how many of you know what's Apache Lucene? Right, so Lucene is an open source search library. Search library meaning search engines like Elasticsearch, Solar, right? They operate on Elastic or Apache Lucene. So now we have also integrated Apache Lucene with MongoDB Atlas also. So if you want to run full text searches, and full text searches are everywhere, right? Think of WhatsApp, think of Facebook, think of LinkedIn, think of Google, think of Cars 24. Every application would have a search bar, and that search bar is being powered by search engines, and those search engines are mostly powered by Apache Lucene, right? So you do not need specific search engine if you are using MongoDB, because we are providing you same capability by creating the Lucene indexes, and we'll come to that piece also. But now let's see some of the examples for indexing, right? Now, in terms of examples for indexing, in fact, yeah. So firstly, there are single field index. So single field index are very basic. I am creating an index or on a specific field. So if I am running this query, let's say I am copying this. A very basic example, and I would want maybe to participate in this so that we can get better value. So this is something, this will help you to optimize your environment also, right? So I am running this query here wherein I am saying that give me the documents where the SSN number is greater than this and less than this, right? So any idea what kind of index I should be having on this? What index I should be creating on this? A very simple question, right? Index of SSN field, of course, right? So if you do search here, you get this response. I already have an SSN index here, but how do you get to, right? So like every other database, we also provide you the explain plan. In the explain plan, you can actually see it's an index scan. If it would have been a collection scan, it would have showed you it's a collection scan. And then you can see which index is being used in this case. In this case, I am using the index SSN in this case, right? So pretty straightforward question this. Now let's see another query where I am saying that give me the documents. Let's say this query, okay. Okay, let's go for this one. Where SSN is between this and this and last name is. Now this time if I'm running the query, I'm getting the data. But if I run the explain plan, you can see it is still an index scan. But apart from index, you would also see that this time it has written 3 documents or 2 documents are written, but it has examined 3 documents. This case, the collection is very small, but if let's say collection is having documents, although you are doing index scan, but you are examining more documents to return less documents, which is what a concept called query targeting in MongoDB, how many rows you are targeting, right? So I think again, very simple question, but any idea what could be the optimal index for this query? If I want to make it an optimal index, so I am saying my SSN number is this and last name is this. So what would be the index that would completely cover this query? Sorry? Compound index, right? So we would need on the SSN plus the last name field. So now if I want to create a very simple index here, so I'll go to create index. Maybe I'll say that SSN is the first field. I am choosing it to be ascending order. I am saying then last name here, and then I'm again choosing to be ascending order. I am creating the index. This index is created. Data size is pretty small. I run the query again. I go for the explain plan. This time I am returning 2 documents. Scanning also 2 documents, because now this query is completely covering the index, right? This is again a very straightforward example, but the idea is you can create compound indexes. There is also a concept of index prefixes, which we will come to now, which is very important because usually in your environment, you will not see single field indexes more. Mostly it would be the compound indexes. Now, what is index prefix, right? Or in this example. Now, let's say you are doing indexing on 4 fields. So you have an index which is a compound index on 4 fields. Field A, B, C, D. 4 fields you have an index, right? Question to everyone, right? If I am running a query field B and C, will that query will the query be satisfied through index? My index is just like we created SSN and last name. This time I am creating an index on field A, B, C, D in this order. A, B, C, D. Now, if I am running a query on field B and C, would this query be satisfied with the index or not?
Anyone, please raise your hand if you have the answer.
Yes. So why not? Sorry.
So your index is starting with the A, but the query on which the fields on which you are running the query starts with B. So it is not part
Right.
of
So it is not part of index prefix. In technical terms, we call it index prefix. What does that mean? And in terms of optimizing, when we talk about optimization, right, there are 3 things. Firstly, it's the indexing because it's the easiest way to optimize. Second is the data modeling, bit complex. And thirdly, we go to optimizing the queries, which usually I have seen developers hide away from that. Okay, we'll look at queries afterwards. But And that is where this concept becomes very important, because if you understand the index prefixes, you would be able to optimize the indexes in your environment, right? So again, coming to this question, if you have index field A, B, C, D, right? 4 fields, so compound index with 4 fields. Now, what kind of queries this will cover? This will cover query on field A, right? A, B, C, D. It will cover on field A. It will cover A plus B. It will cover A plus B plus C. And then it will also cover A plus B plus C plus D. So basically, prefixes of the ABCD is being covered. What is the prefix? You know, A, AB, ABC, ABCD. If you do BC or you do C, it will not happen. Why? Because like relational database, Mongo also used B-tree indexes, right? So B-tree indexes, basically they traverse across the path. So the ordering of fields inside the index is very important. So if you use the unordered query, then in that case, index might be used, but it won't be the optimal indexes. So in your environment, again, if you have MongoDB, if you are facing performance issues, if you are facing cost issues, and your cost is high because there are certain queries that are spiking the CPU, what you do is identify the queries. How to identify, we will come to that. Once you have identified the queries, see the explain plan. We have seen how to see the explain plan. Through that explain plan, then you need to see whether index prefix rule is being satisfied or not. If that is not, that is something that will help you to optimize the query and of course save the cost. Now, on top of this, there is also a concept of ESR in MongoDB, right? Just give me a moment. So anyone knows what is the ESR concept? I think in one of the sessions with the specific team, I have covered this, but does anyone know what is ESR concept with respect to indexing in MongoDB?
Anyone? Yeah.
It actually help like how we name the compound index. So E means like whatever query we are forming, let's say we are doing some equal comparison. So we have to name this first, and then we are using some kind of sorting and range. So ESR means I need to, let's say I have 3 field A, B, C, and I am doing comparison on field A, and doing sorting on B, and then doing some range query on C. So ESR rule help me to design the index, like name the index. Like I need to use equal query first, then sorting field, then comparison field.
Absolutely, absolutely correct. Right. So ESR is a very important. It is very rightly said. So it means if you have a query in which you are doing equality operators, for example, give me the documents where name is Nitin, right? And you are also doing the range operators where the date of birth is between this and this. So I'm doing range operator, greater than, less than operator. And then you are also doing a sort operator. So if you imagine, most of the queries are like this only. We are doing multiple equality operators, multiple range operators, and then sorting. So the rule says that the ordering of your index should be in ESR format. The fields on which you are doing equality operator should be placed first in the index. Then the fields on which you are doing sorting should come after the equality. And in the end should come the fields on which you are doing the range operators. You might say why? It's a concept in itself, because the B-tree leaf grows in a manner that this is the optimal way, right? But in short, if we have to explain, if you are doing index tuning, if you are trying to fine tune indexing for your environment, and you have equality sort operators, and it is also possible you might not be using range. So then the rule is ES, or you might not using sort queries. Then the rule is ER. But the ordering has to be first E, then S, then R, right? if you apply this rule, mostly in 99% of the cases, the indexing would be, it would fully cover the query, and you will get the maximum value with minimum resources for that query. So do remember, firstly, index prefixes, the previous concept, and secondly, the ESR. These two concepts combined mostly cover the best practices for the indexing perspective, right? Now, we will try to apply it here, and then I need an answer from everyone here that what would be the optimal index for this query. Just follow the ESR rule here, straightforward, and what would be the index here? So my query is, I am doing query where bed type is in this, first review is less than this, last review is less than this, and then I am ordering by this field. So let's take 5 to 10 seconds, and maybe you just have to apply ESR rule. Just see that which fields you are doing equality operators, where you are doing sorting is ordering, and finally where you are doing range queries. Anyone?
Anyone in their audience?
Okay, what is the field on which we are doing equality operator here? Or range or sort, anything, if anyone wants to. So sort is pretty clear, right? Sort we are mentioning order by bedroom and price. So we know that out of ESR, S is bedroom and price, which is going to come in between, right? Where we are doing range. First review and last review. And the bed type, equality, right? Usually dollar in operator or in can be considered as a range also, right? Even if it is, range also, but even if it is in this query, right? So the order would be first would be sort, equality, then sort, and then range. So my order would be bed type would come first, then would come sorting. So bed type, bedrooms, price, first review, last review. So 5 field compound index in the order of the way we discussed ESR, and that is going to cover this query, right? So, so why this is important, right? Again, an example from a customer. So let's say your queries without the optimal indexes, if you have mixed up the ESR fields, is running in 5 milliseconds, which is a very good time for a query to run. Might be a good time based on the application, but the occurrence of that query is maybe, in every minute you are running that query 10,000 times. Now 10,000 times into 5 seconds versus if we have an index because of which that query is running in 1 millisecond into 10,000 times. It is 5x the performance improvement. And remember, this is not the only query which might be running in your environment. There might be 1,000 other queries running or transactions running. So these small changes can actually impact the overall performance, especially the sort operator. If the sorting is not done through indexes. So, okay, a question to everyone. If we do not have index for sort operator, how do you think database does the sorting? So let's say I'm saying, give me the documents where company name is Cars24, sort by the sort by the customers, Cars24 customers revenue, right? Whatever customers revenue Cars24 is getting. So I'm doing sorting in this space. If I do not have sort operator or sort index or index on the field on which I am doing sorting, how would that query at the database run? Any idea? So what would happen is, in that case, instead of directly going to the index, fetching the documents, what MongoDB or any database would need to do is go to disk, because that data is not in RAM. Go to disk, fetch that data into RAM, do the sorting, and then give the result to the application. Versus if you already have an index, that data is already sorted in RAM, just go to RAM, from the index, get the sorted data, and that's it. And that is where, if you have sort operations running from disk, that means you will see your CPU cycles 2x, 3x, 10x also. So very easy way to optimize is identify the queries where sorting is happening and index is not proper. That is a very easy win for you. Right? Now we also have few index options, which I think I discussed on the index slide, but you can create unique indexes. If you want to have a unique constraint, you can create partial indexes. So example is index only the documents where average rating is greater than maybe 3.5 for a restaurant. So only those documents I am, indexing. Or sparse index only the field documents particular field exists. If that field does not exist, do not index those documents. So these kind of things can also be done, using the MongoDB indexes, right? And of course, indexing does increase your query performance, but do remember, having too many indexes can also hamper the write performance and update performance. So it is not like, and maximum limit for MongoDB in a single collection is 64 indexes. And 64 is a very big number. Ideally, you should not go beyond 15 indexes for a single collection. Because what would happen is, for every insert, those 15 indexes would also needs to be updated. Those leaves of the B tree indexes. So this thing should be kept in mind. Any questions on the querying and indexing before we go to the transactions? Because now we are going to go to ACID transactions. Again, as I mentioned, there is a big misconception that NoSQL in general and MongoDB being a NoSQL database, they do not do transactions. They cannot do transaction, right? And I mentioned that one of the banking customer is building their core banking system on Mongo. But we just want to show you how we develop transactions, what are the features we apply, and how does it compare with relational databases.
So any question from the audience for indexing? Anyone? Cool.
Okay. So let's talk about the transactions now. Now, if you think about transactions, right? Usually transactions, when we talk about transactions, we are talking about a very basic example, the ATM example that everyone gets. You go to an ATM, you start your process, you insert your card, you put something. Ideally, what should happen is, if the transaction gets aborted in between, right, then amount should not be deducted from your account. So transaction should completely abort or completely go success. There should not be a inconsistent state in between. And when we talk about transaction, because in the SQL databases, we do a lot of normalization, multiple collections comes into picture. In MongoDB, first of all, we say that since you can denormalize the data into a single collection, so most of the cases, maybe 90% of the cases, you actually don't require multi-document transaction because your data is inside the single collection itself. So, and single collection, MongoDB has always been atomic. So we are always been atomic for single documents. But then of course, there are use cases like, e-commerce, inventory management, order management, or the banking example, wherein transactions are required. We cannot get away with that, right? That is where the multi-document transactions comes into picture, where we are actually talking about transactions across multiple collections or multiple databases or across multiple shards also, horizontal shards also. So Mongo, first of all, MongoDB does provide you the transactional guarantees, both for replica set and sharded clusters. What are these? We'll come to those. And what we use is, we use a concept called snapshot isolation. So, and does snapshot isolation, people working on relational databases, or maybe, people from the engineering team who love to know about the, backend databases, how does database operates? What is snapshot isolation in terms of transactional guarantees? Anyone? People using MySQL, Postgres, ever heard of snapshot isolation or serializable isolation? Anyone? Okay, so there are different ways in which consistency can be achieved, right? So basically, when we talk about transactions, ultimately we are talking about isolation versus consistency. Isolation means that two operations are happening. Are they isolated from each other? And even if they're isolated from each other, from an overall application perspective, are they consistent and not? And this is what we are going to talk about. And that is where, how did MongoDB happen to have transactions is because of the two, I would say, key moments or key decisions taken by MongoDB as an organization. Firstly, the acquisition of Tiger storage engine. So we acquired Tiger storage engine in around 2013, and this storage engine was created by a person named Michael Cahill. Michael Cahill is the person who has created transactional guarantees in Postgres database also. So post developing transaction guarantees in Postgres, he started his own company named Tiger, wherein he built a storage engine, pluggable storage engine, which could be plugged to any database and make it transactional compliant. MongoDB acquired that company Tiger, and with that also came the expertise of Michael Cahill. And then the work started of integrating Tiger transactional guarantees with MongoDB, right? That was the first pivotal moment. And then the second moment was, there was a paper published by Google, which was around the, Lamport clocks. So if you are talking about distributed databases, meaning a cluster or a database spanning across multiple nodes. So usually time on versus the time on other node could have few millisecond, microsecond differences, even seconds, depending upon where the node is being deployed, whether it is physically close or physically far. It could have huge latency also. Now, to get that transactional guarantee, you need something to have common timestamp across the clusters. Otherwise, you will never get transactional guarantee. If your transaction is basically spreading across multiple nodes, multiple clusters, right? That is where the paper published by GCP around the Lamport blocks that enabled us to utilize the same concept with MongoDB, integrating it with Tiger, and that is how we were able to provide you snapshot isolation transactional guarantees. Now, once we acquired or once we built that capability, now, if yesterday MongoDB did not have transactional guarantees and now we are claiming we have it, how do we prove it to the customers? How do customers trust us? That is where Jepsen tests come into picture. People who have been working for databases long, they might know Jepsen is a gold standard organization that does the company to vigorous tests whether the product is software transactional compliant or not. And MongoDB, along with Oracle, SQL Server, and Postgres, and I think 2 more relational databases have been granted as the gold standard for the transactional guarantees. So that gives customers the confidence that we have gone through the same rigorous testing as the other customers have also gone through, right? So which is just a moment. Yeah. Now, this is what the process of going through that testing looked like. First, we applied for transactional guarantees in version 3. They rejected us. Then we applied in 3.2 with some improvement. There were some challenges found. And remember, that made it public that we are transaction compliant until we got this. Then, so you can see multiple iterations went through. And finally, in 2020, so 2018, we got for the replica sets, and for 2020, we got for sharded clusters. Eventually, that time, 2020, MongoDB was given gold standard across clusters, across zones, across locations, across collections, that we are gold standard as per Jepsen test for transaction compliant. And that is where you see a lot of banking organizations, the likes of Barclays, the likes of, in India, we have SDFC, ICIC, Upstocks is using it, Zerodha is using it, many customers. These are just the few that I am naming, but many customers are actually using MongoDB for transactional use cases because we are compliant with the Jepsen test, and that is what they usually look for. So this is the overall journey. As you can see, it's not a very easy journey. We had to do a lot of changes. We faced a lot of failures in terms of getting these transactional guarantees, because that is not simple. If that would have been so simple, so today MongoDB is the only SQL database which is Jepsen gold standard. If this would have been so simple, so easy, other NoSQL databases also. There are a lot of SQL databases, but with the benefits of SQL plus NoSQL also, right? That is where we had to go through a lot of testing there. And just to draw a comparison, again, everything is related to having flexibility, providing the developers the right tools, and increasing the developer productivity. The syntax that you have for MySQL and MongoDB, you can see it's pretty similar. So you start a transaction, you do certain things, then you commit the transaction. The syntax has been kept as simple as possible so that, again, as a developer, you don't need to learn new things. You know it is gold standard, you trust it, then you build it with the simple syntax. Right? So that's how we got the transactional guarantees. And MongoDB is now transactional compliant. I have talked with few people within Cars24 also, wherein they have the misconception that Mongo cannot do transactions or cannot provide similar transaction guarantees like relational databases, right? But it can. So if you have a use case, definitely we can, look into that. Any questions on the transactions piece? So this is something, this was very specific that we wanted to cover and was asked by the team that to cover this thing. Any questions, anything that you have? Yeah.
Does MongoDB provide any pessimistic logs on the document level?
Yes. So in MongoDB, we provide at the locking is, or consistency is at the document level or at the field level now, right? So at the field level also you can get that. So a particular field will be logged, in other fields you can basically change. Yes.
Hello. So I have one question. Like when we are starting this transaction and we are committing some query. So if say I have multiple slaves in my system will all the data be consistent over that? And after committing it, and we are reading it, then it will be available in that.
Yes. Yeah. So I think great question here. So there is a concept of right concern in MongoDB. So right concern means that when you will get the acknowledgement from the application. So it could be that you want acknowledgement only after writing to primary or after writing to majority of the nodes. In transactions, it is constrained to majority of the nodes. So once that transaction has been written to majority of the nodes, that means few secondaries also, then only application will get acknowledgement, yes, the transaction has completed. So you will always see consistent data. So answer to your question is yes, that is being done.
So by majority means to all the nodes, or
No, majority means if 3 node cluster, then majority is 2.
okay. And if we are say reading some data, then is there any chance that we are getting the old data?
No, if you are doing majority writes, then no. Although similar to write concern, we also have read concerns. So if you want to read only local, so if you are reading from primary, no chance. If you are reading from secondary, you need to specify write read concern also. That what is the write read concern for this kind of operation. If you, so it's a tunable consistency. If you want, you can tune it accordingly, but you can have it to be very strict consistent also.
So what I understand, there will be two things. One will be primary and one will be secondary one. So if we are reading it and we have to mention that we want to read from the primary one, and we will get the consistency from that point of view.
Yeah, you can get the consistency from secondary also, but in that case, you need to specify right read concern. What is the correct read concern for that query? If you are reading from primary, you don't need to specify. Primary would always give you the consistent data.
Okay.
Yes.
Hello. Is there any rule to decide majority number?
No, no, majority is always, so it's basically half plus 1. 3 node clusters, half is 1.5 plus 1 means what is the next value? So 5 node cluster, majority is 3. 7 node cluster, majority is 4.
Basically half plus 1.
Half plus 1 or half plus 0.5. What is the next round of value for that, half value? Yes.
Since both Postgres and Mongo providing ACID properties, right? So is there any performance check?
So, yeah. So I think from the performance perspective, the way relational databases are built versus how MongoDB is built, there are few cases where we have seen Postgres outperform MongoDB in transactions. That has been there. But it is very use case dependent also. But again, 90% of the use cases, you do not require transactions in MongoDB. So what I'm trying to say is, if let's say there is a use case where you do not require transactions, MongoDB will outperform Postgres by a huge margin. If it is a transaction to transaction comparison, for certain use cases, Postgres might be 10% better. That is a possibility.
In primary section, I'm asking about the failover scenarios.
Yeah.
Suppose there are 5 slave nodes, and when committing the transaction over one slave node, it's getting failed. So will my transaction be rolled back from all the things, or will it retry at the Mongo level?
Okay. So again, there are a lot of settings with the database, but there is also a concept of timeout while you do a query. So let's say you have a 5 node cluster, 1 primary, 4 secondaries. You are using write concern majority. So that means out of 5, 3 nodes should be written. Data should be written. Now we are saying out of 5 nodes, 3 nodes, maybe the 3rd node is not reachable and data is not being getting written, whether I will get acknowledgement or not, right? In that case, data would still be written to primary and one of the secondaries, but in the acknowledgement after the timeout, you will get an exception. So you know that there is an exception that has been thrown and you can take action on that.
Okay, that will be different from complete failure.
Yes, yes, definitely. So you will not lose any data in this case, but you will get an exception that maybe out of three, two nodes were not available. So I'm not marking my application to be basically, to be down. I'm taking the transaction, but I'm also giving you exception that this has happened. Now you want to change that behavior. If this is a frequent operation, you basically choose it to be right concern of one or majority or two based on your requirements.
But what will be the solution to like commit that change to the one slave node, which was not able to write that one?
That will be done by MongoDB automatically once that node comes up.
Okay, Mongo will automatically
Mongo will
handle
take
that.
care of that.
Okay.
Yes, yes, yes.
Thank you.
Right. I think now we want to cover the data modeling. I think data modeling in itself is a very huge topic. If we want to talk about data modeling, it might be 3-4 hours, 3-4 sessions if we want to cover in detail. So I'll not go in depth. If there are a specific questions with respect to data modeling, happy to take those. But what I'll just lay out the way or the process of how you think of doing data modeling in Mongo, right? Which might be helpful for the team. So this is how the overall process looks like. So it's a 4-step process. The first step is in your application, whatever application you are building, you should know what are the entities that are there. And you should quantify the data size. What do I mean by that? Right? So what I mean by that, so for example, this is an example for a library management application, right? In this case, I should have the functional requirement of the application, which you should already have if you are building your application. You should know what the application would do. So if it is a library management application, there would be readers, there would be librarians. What all the things would readers do? What all the things would librarian do? For example, librarian should be see a list of book reservations, right? Librarian should be able to lend the books to the readers. He should be able to, in the software, mark the books as returned. These are the basic things, the functional requirement. Once you have that functional requirement, you basically put that in a chart. Okay, these are my entity names for my library management system. Book, user, author, different entity names are there and different properties. So this is the first step. And if you are building an application, you should already know the functional requirement. Second is the workload. You should know your workload. What I mean by that? So again, for library data, how many active readers are there? So think from your perspective from Cars24, if you are a building application, what are the active users? What are the peak users, right? For that particular application, how many books are there? Maybe how many cars are there, right? Rough example of that. Then on weekly basis, estimate of how many books would be borrowed or not. So no workload is again an important thing. And what is the performance requirement? Maybe if I want to book, basically, borrow a book from the library, what should be the overall response time for that query? 300 milliseconds, 5 seconds, whatever. So have a good idea of that. That's the second step. So you create this table that, okay, my write operation, which is reserving a book, is actually happening 4,200 times a day. Maybe 4,200 times a day it is happening. Then my read operation, which is finding books, right, is happening 100K times a day. So as a user, I might think from Amazon perspective, not from the book perspective, right? You go to Amazon, search for products multiple times, one or two products usually. So your searches are maybe 20, but your buy is one, or maybe this number is huge difference. Your searches are 100,000 and you buy one product. So reading a book or finding a book which is a read operation, is a much high frequency operation in this case. So first step, no entities. Second step, no workload. Build this kind of chart of your workload so that you know what actually you are optimizing for. This is the second step. Thirdly, then comes the relationships, one to one, one to many, many to many. How do you handle those relationships? Do you need to do embedding? Do you need to do referencing? I see people usually starting from this point, but if you don't know entities, these steps usually gets wrong, right? Now, in this case, whether it's a one-to-one relationship, whether it's one-to-many relationship, whether it's many-to-many relationship, we would know. And then whether to embed or reference, this is basically the guide for referencing or embedding. So these slides would be shared with everyone, but if you are thinking whether to denormalize everything into a single collection or whether to have some level of normalization or should have a mix of things, this is the slide which is we called a cheat sheet in terms of referencing versus embedding in MongoDB. Now let's take a couple of examples here. For example, simplicity. If let's say you are building a very small application, you know that number of users are not going to be much, at least let's say for first 6 months, 1 year down the line. Then simply go for embedding. Do not think, just go for embedding, because no scale, less number of users. Do not waste time on data modeling, just go for embedding. It is going to work best for you. As the application grows, scale increases, data size increases, you may come back again and then try to remodel the database. And then remember, remodeling the database in Mongo is not going to be as difficult as in relational, because you can do schema changes without downtime. If you link back to the property of document model, you can add or remove fields without downtime. So remodeling can be straightforward here, right? Then the second and third point are the things that you are accessing together should be stored together. We saw a few examples, in the insurance example, the banking example. If you are doing those, then do go for embedding. Then comes a very important point, the cardinality, right? Cardinality or document size. These are two important factors. Now, let's take an example, this case. So let's say there is a book and there are reviews for that book. A book might have 1,000 reviews. Now, if I store all 1,000, and then from an application perspective, when I am seeing the book, usually, and again, if we compare with the AWS, Amazon website, if you are seeing the product, if now you go to Amazon.in and you see a particular product, you will see at the bottom reviews of that product are also listed. Because as a user, you want to see reviews along with the product itself. But if a product has 10,000 reviews, would you store all 10,000 reviews in the single collection? No, right? Because then it will become a huge collection, a huge document in itself. Now, coming back to Amazon, in Amazon, what you will see, they will show you first 5, 6 or 10 or 20 reviews on the product page, and then there will be an option for load more. If you click on that load more, it will have a separate API to reviews collection, and then all the 1,000, 10,000 reviews would be shown. Similarly, what you would do in Mongo is, in this case, in your product or books collection, store only recent reviews only. And then have a separate collection called reviews, which will be called, usually which will not be called, because people 90% of the time look at the top reviews only. But if they want to see more reviews, they can click on load review and go that side, right? So this is again a consideration to reduce the document size. We can do that. And of course, there are other factors like update. If you are denormalizing everything and duplicating the data also, and it's a update heavy workload, then it is recommended to not denormalize, not embed, and basically go for the referencing. So this is the rule book. Basically, once you have a use case, go through this, and then based on that, you can do that. And finally, two more things. There are certain design patterns. People, engineering folks would know there is actually a separate segment in engineering around design patterns. But design patterns are what you apply on top of your schema to improve the performance. So there are many design patterns, right? It is a huge topic in itself. So we'll not go into detail, but I'll take a very small example with one of the design patterns, which we call it as a computed pattern. Just to give you an idea, how does design patterns actually help you, right? So let's take an example that you want to calculate the average book rating. Or again, going back to the Amazon example, let's say you want to do the average rating of the product if you want to calculate. And this is how the collection looks like, right? Now, one way is that what you do is every time a new rating is being added, you basically compute the average rating and display it to the customer. Will it be effective? No, because every rating being added, you are going to compute the average rating, which is not going to be effective. Now, what we are saying is you store, instead of computing the average rating every time, you store the total ratings and the number of ratings, and you keep changing that value or keep incrementing those values by 1. Whenever a new document gets inserted, increment that value by 1 and then add the rating to the total rating. And then when the user asks for it, then only calculate the average rating using this aggregation pipeline. Point is, do not do the computation every time when basically it is having. Basically, find an easy way, or computed pattern means do a computation not on the runtime, but pre-compute the data in a better way so that it can be efficient and less CPU, intensive. That's what computed pattern is. So using these patterns, this is one of the examples. There are many other examples, right, in terms of pattern. For example, one of the pattern is approximate pattern. So if let's say you are showing the number of views for a page, if let's say that number of, or Zomato these days shows you how many orders they have done in a single day or in a single week. Do you bother if that number is 1 million or 1,000,001? You don't bother. That doesn't matter, right? So we can do approximation there. Point is that instead of updating that number of orders in real time, you can update it every half an hour. Every half an hour, just run a batch job to update from 1 million to 1,000,010 or 1,000,000, something like that. Instead of updating it every time a new order is being placed. Because as a user, for me, it doesn't matter. 1 million or 1,000,010, right? If maybe every half an hour or every 10 minutes, it gets updated. So that's an approximation pattern that instead of doing 1,000 operations, now if you are doing every hour, you are reducing in 1 hour only 1 operation. So you are saving a lot of CPU cycles for the cluster. That's what design patterns are, and that you can use. And finally, there are a lot of anti-patterns also. These are anti-patterns that you should avoid in your application. One of the things we talk about, product reviews, storing every reviews together, it would be a bloated document. It would be a massive array. So, which is an anti-pattern. Document size would be high, it will create a bottleneck. Or if you are creating unnecessary indexes, then your performance, insert performance would go down, right? And then there are anti-patterns. So these anti-patterns you should be careful of. And with respect to design patterns, right? These are the references that you can have. It's a big topic in itself, data modeling. So there is also one course on MongoDB University, which I think Arun will talk about in the end, but it is freely available to everyone. The link is university.mongodb.com or learn.mongodb.com. And there are a lot of free courses available with respect to languages, Java, C Sharp, or with respect to MongoDB internals, with respect to data modeling, you can actually start your learning journey with those also. And of course, there are QR codes for the patterns and anti-patterns blog also here. Right now, I think let's now talk about MongoDB Atlas, which is I think is going to be last topic for us today, which is MongoDB Atlas, which is nothing but managed service we have for MongoDB, right? Which is Atlas, right? So I think how many of you are using MongoDB Atlas today? Maybe raise of hands. Okay, so I see a lot of people already using MongoDB Atlas, but yeah, many of you are also, okay. So see, the main thing with Atlas is, if I have to showcase you, is that first of all, Atlas is available on all three major cloud providers. As I mentioned earlier, if you want to build a cluster across cloud providers or use
Nitin, yeah, if is it possible, if you can please zoom in.
Yes.
Better.
So I think everyone story with GCP, I think 6 months back. So there was a customer in Europe wherein the entire data for that customer from GCP got erased. Entire data for that customer. And that customer was in the stock market domain. You can imagine the loss that company would be having. Why did they got saved? The new CTO they appointed, the first thing that he did is he built a strategy wherein daily backups were also stored from GCP to AWS. Although those were 24 hours behind, but still a backup copy of entire company. So imagine you come to Cast24 office, open your laptop and screen is blank. Everything is being wiped off, completely wiped off. All applications, your data, your customers' data. That is what happened to them. You can imagine the financial loss that the company would have gone through, right? So they had 24 hours backup data in AWS. They had multi-cloud strategy. That is why multi-cloud is important, right? So that is where a lot of people prefer to have a separate cloud provider altogether, wherein they can store the backups or have DRs, right? But Atlas helps you to have that capability. Right? Now, so by default in Atlas, we have a 3-node cluster, out of which one is primary and two are secondaries. Primary takes your reads and write, but secondary can take your reads, not writes, but secondary can take your reads. And this is what we called as a replica set, 3-node replica set. You connect the cluster, not individual nodes. So if any node goes down, another node becomes from secondary to primary. Application does not know that. Your connection string remains same. You do not face any downtime. This is completely being handled by MongoDB at the backend. Right? That's what a 3-node cluster is. We have separate nodes like analytics node also. So what is analytic node? Let's say apart from your operational workload, you also want to do analytics queries also, complex analytics queries on your same system, right? You can have a separate node here, which would be in real-time sync with your cluster. And then you can target only this node for running complex queries on this, so that these complex queries does not interfere with your operational workload. Yeah, I think there is a question.
Is there any downtime when we are upgrading the cluster tier?
No, no downtime.
Because we faced this issue a while back, like a month back. We were upgrading our cluster. It was a single node cluster and we were upgrading it to the next tier. And
Single on Atlas.
Yeah. Okay. So I think it was the base layer, the base version. And then we were upgrading it and we were making it to a replica set of 3 and then our applications like stopped.
So On Atlas, you can have a minimum of 3 node cluster. This tier is a free tier.
Yeah, right.
So
We were on
from
free tier.
from free tier to replica set, definitely it may downtime would happen. Yes, because see, free tier hardware is shared. That's a shared. Now we are moving from shared architecture to dedicated tier. So that's a different thing. But we have tools which can help you to avoid that. So maybe in future, if you are doing so, contact with RN or me, and we can help you with that with those tools.
Okay,
Yeah.
thank you.
Right? And then you need to select which cluster tier, basically what is the resources, what is the CPU, what is the RAM. So we have clusters ranging from 2 GB RAM up to 768 GB of RAM based on the requirements. And for every tier, you will see you can you get some CPU, RAM, memory here, and then storage also. You have storage auto scaling, and you have the cluster auto scaling also. From a best practice perspective, do enable cluster auto scaling so that Atlas can scale up and scale down based on the traffic requirements. So this could also help you save cost, right? So this is there. And then finally, of course, you choose the MongoDB version of which you want to deploy, and you can actually deploy the cluster, right? So this is how you deploy the clusters on Atlas. Once you have deployed the clusters, in terms of monitoring, we provide you many metrics. If I go to the bottom, you can see there are a lot of database level metrics. These are MongoDB metrics. These are, again, hardware metrics are there. So anything happening with respect to database, anything happening with respect to hardware, you can identify with these metrics. It helps you identify what challenge is happening. And couple of really cool things that we have is, one is the query insights. What does that mean is which query is troubling your system. If you want to identify those queries, you can go to query profiler. And for me, this is a demo database. I do not see anything, but here you will see all the slow operations that are there in this graph. Once you see these slow operations, you can actually see the explain plan of those slow operations also directly from here. So this is a starting point of your optimization. So while doing the indexing, we were discussing how to identify the query. So query profiler is the way through which you can identify the queries. And then once identified, you can create appropriate indexes. We also provide you something called performance advisor. Based on the profiler, it automatically suggests you what index you should create. So it will suggest you indexes also. So in this case, it is suggesting me 2 indexes in this case. And it was also giving me that these are the sample queries which are running on the system, because of which I am suggesting this index to be created. So if you see, I ran this query, policy.policy type for the demo, which was not indexed. So it is suggesting if you would have had this index, that query would have been better. So it will suggest you indexes also. So that's one of the key benefits that we have from the performance advisor perspective. Now, one very important thing which I think which was asked was around security, because today security is very important for all the organizations, right? Now, what MongoDB provides you or Atlas provides you in terms of security is, firstly, the database access. We do RBAC, right? Role-based access control. So you can create users. You can actually specify certain rules for those users, restrict the user authentication or the level of access for the users. In terms of network access, basically, if you have your environment in GCP or Azure or AWS, you can do peering. It is very straightforward. You need to select cloud provider and need to provide the details of your AWS environment. And once you do that, you initiate this thing, a request would be given, sent to your AWS account. Once you accept that, private tunnel be created between Atlas and your AWS environment, and it will be secure processing after that. So peering and private endpoint, these are the two ways through which you can create secure tunnel between MongoDB Atlas and your environment, right? So from security, this is there. There are few advanced security features also. So if you are storing PII data, if you want to encrypt the data, so encryption is also provided. So you can do encryption and you can specify your own key, which is in your environment. If there is a requirement for database level auditing, you can enable database level auditing also. If there is a requirement to encrypt only certain fields. So for example, if you are capturing Aadhaar card number of your customers and only encrypt that number. So we do provide you field level encryption also, that you do the encryption of that particular field. And with all these security capabilities that we have, so key thing is that MongoDB is able to acquire all.
Hello. Can you tell me how we can enable that encryption on field level?
The DB level or field level?
Field level.
Okay. So field level encryption cannot be enabled through Atlas. So it can be enabled through driver. Whatever driver you are using, Spring Boot, Java, through those drivers, we have built the capabilities directly into those. But we can share the documentation and the quick start, and then post that you can do that. I think one of the teams within CAS24 that field level encryption. But it's a straightforward process. The encryption decryption is taken care by the MongoDB driver itself. Once you set it up, you don't need to write the encryption decryption logic. It is taken care by the driver.
Okay.
Yeah. And because of all the features, we have attained these security assurances or compliances or certificates in case in future CARS24 undergoes a security audit and they require any of these certificates from us, we can directly pass on those certificates, signing an NDA. All these certificates would be provided from MongoDB side to the CARS24 team. This is going to be there, right? Now, one last thing is that we want to talk about is that Atlas is a managed offering for MongoDB database, right? But you might have heard the saying data platform. Why are we calling just a managed service a data platform? What is the reason for that, right? To understand, let's see a common methodology or common, I would say, mistake that usually, a lot of organization does is. So let's say as an organization, you start with 4 or 5 applications, right? Usually we in the beginning, let's say 10 years down the line, you started an application, you would choose a relational database. What would happen is your performance requirement increase. Now you use for certain databases or applications, you require a caching layer. Now the requirements increase further. Maybe you require a key value store. You require, for GenAI purpose, you require a vector store. For time series use cases, you require a time series database. And then for graph requirements, you require a graph database. And then for document requirement, you require a document databases. Over a period of time, what you would see is a lot of these red lines, which are ETLs. So you are basically moving the same data from one service to another. And the movement of this data is not adding any value to your service. This is just unvalued movement of data from one service to another. The other challenge is now your team, who was maybe specialist in relational database, needs to know key value store, needs to know vector store, needs to know time series, needs to know graph database, document database, data lakes, everything. You might have separate teams for them, or one team that might be, a jack of all trade kind of team that needs to know. Now, in this kind of scenario, what we are proposing is that we will bring a data platform, which is Atlas. What we will try to do, and this is how for the overall landscape it would go like. if we want to simplify this stack, so what we are saying is that MongoDB provides you something which called you Atlas search. Initially, I told that we have integrated Lucene with Atlas, and that is what we are calling Atlas search. Similarly, we also have a vector database integrated with Atlas. Similarly, like you create collections, you can create time series collections. So what would happen is that over a period of time, using Atlas, you can actually simplify your stack, wherein in this case, you see that you are not moving data from different services, and within one service, you are able to fulfill most of your use cases. Of course, we do not provide data warehouse. MongoDB does not have a data warehouse capability. That is where you would still need to do the ETL. And that is something where MongoDB is not going to go in future also, because we are a transactional database. But some of the other features like search features, GenAI capabilities, building RAG models, building agentic systems through the vector searches, or doing time series collection, this can be done through single platform, which is what we call Atlas Data Platform. Right? That's the whole idea here. Now, again, you might be thinking, why should I not go for Atlas search or Solar? Why do I need MongoDB Atlas search, right? So if you see, if you are using Mongo or MySQL or Postgres and a search engine, you need to do this ETL in between and maintain this ETL throughout the life cycle. What we are saying is that within MongoDB Atlas, just like you create your normal indexes, you create a search index, and within minutes, you can get started with writing full text queries. And similarly, just like you create normal indexes, you create vector indexes, and you get started with your vector search or GenAI capabilities. So otherwise, you would have Mongo, you would have Elasticsearch, you would have Pinecone, Elasticsearch for your search capabilities, Pinecone for your GenAI capabilities, or Quadrant for your GenAI capabilities. Instead of having multiple systems, and then you are moving the same data to different systems. If without movement of data within that single source, you are able to provide those capabilities, right? That's where the benefit of unified platform would come into picture. That's what our data platform is. This is about Atlas vector search, right? And so these are some of the use cases that the vector search fulfills. The MongoDB, I think these are common for any GenAI related searches like semantic search. So does anyone use semantic search? What is semantic search in terms of GenAI?
Anyone?
So let me give you an example, right? So when you do full text search means the search would be done based on the text. I think today we have England cricket match, right? So let's say after the match you go to Google and you type India beat England, or you type England beat India. The kind of responses, if you are doing search engine, text search engine, you will get same results because the text is same in both sentences, but the meaning is completely different. Now, semantic search is search with a meaning. So if you type England beat different set of results, and if you type England beat India, you will get different set of. That is what semantic search is, because it is powered by vectors. It is not powered by text. So that's the difference, or that's the power. If in your application you want to build search with a meaning, that is where you go for semantic search. And of course, recommendation engines or image searches, video searches, these are the other use cases, right? So finally, I think we have a small quiz also, but before that, Aryan would talk about MongoDB University.
Thanks, Nitin. So I think Nitin briefly covered what MongoDB University is. Yeah, you had a question?
Yeah. So it was for Nitin. So basically, why did we decide to decommission devising?
Sorry?
Why did MongoDB decide to decommission devising?
Yes. So I think Cars 24 was using it heavily. I know that. See, the reason is that uh, MongoDB is predominantly a database company, right? The time we acquired, when we acquired Realm, which is what we build into devising, we thought we might go into that domain. But eventually, what we felt that we were not able to compete with the likes of other devising providers because that is not our specialty. So that is why, although it is very easy on Atlas, if your data is on Atlas, you could do that. But the kind of features that other devising providers were providing, right? Because we are predominantly a database company and we had to do a lot of innovation within database. We could not spend much R&D revenue or manpower into devising. And that is why as an organization, we decided that this is something we will pass on to our partners. And of course, I know there would be challenging, but I think Firestore is also now becoming our partner in terms of moving this. So I think you are moving to Firestore only, right? So that's the key reason. Of course, this is an organization level decision. So that's a different matter. Revenue would have also played a part in that. Yeah.
And I would just like to add one point, as Nitin mentioned, right? Version 8.0 is one of the biggest, I think, examples of where we are trying to set up a foundation as a database company, right? We want to specialize in what we do best. And that's where we have brought in 8.0, where Nitin did mention that you are going to get 20 to 30% performance improvement. So I'm going to quickly cover MongoDB University, which I think just before covering that, how many of you have already visited MongoDB University or you do use it for your learning purposes? Just raise out your hands if anyone is aware about this portal. Okay, I think people are not aware about it. So as you can see the URL, which is learn.mongodb.com, and it is our absolutely free online learning portal, which has a lot of content. So it has four kind of contents. First, starting with a bite-sized video. It is a 15 minutes video where we try to consolidate all the relevant information for whatever new features we come up with, right? And which is followed by a hands-on lab where you can also demonstrate as well as have a real experience without creating a sandbox environment on Atlas. Definitely you can, but you don't need to do that just for learning purposes. Followed by, there are instructional contents as well as knowledge check in each and every content that we deliver on MongoDB University. One very important thing that I want to highlight is, as Nitin was earlier mentioning, that MongoDB University is something all the employees internally also, as whenever we join MongoDB, are required to complete certain courses to get a hang of what MongoDB is all about, right? So these are dedicated learning paths for different personas that we have in the IT space. So if I talk about developer, there's a developer learning path which talks about what are different MongoDB basics, what are CRUD operations, aggregation frameworks, indexes, and it's available in different programming languages. Followed by, I think, which is the crux of any application, wherever we are building any application on MongoDB, which is data modeling, right? So this is also very, I would say, important path wherever you think you want to develop your skills on MongoDB. So you can always go to this learning path. I will be sharing this, as we mentioned, we are going to share it across the organization. So you can definitely leverage this learning path. And then we also have few GenAI learning batches. We've recently introduced them. Yeah, and this is something that I specifically wanted to highlight, which is we also provide you some certifications, which are Atlas Data Modeler, Atlas Admin, Atlas DBA for people who are managing databases in and out, and Associate Developer. It is also available in all programming languages with which MongoDB is compatible and integrated with. Thank you.
We also have one quiz. So I think we would encourage everyone to participate it. It's a fun way of doing quiz. You can do it from your mobile also. You can do it from laptop also. We will be displaying a QR code and maybe a pin. You can go to Kahoot, either mobile app or the site there, and we can do that. I'm just opening that link. It's a 5-minute quiz at max. So recommend everyone to participate, right?
And just to add a little flavor to it, what we have done is we have also kept some prizes, right? So first 3 people who are going to show up on the leaderboard, we are going to provide you some Amazon voucher. So do participate and try your luck.
Yeah. So you need to go to www.kahoot.it and either type in this pin or you can also provide this QR code. I think people are joining. Please provide your actual names because otherwise we would not know who has won and Aryan would keep that voucher with himself. Let us know when you are ready. We will start the quiz. So answers are time-based answer. The more quickly you answer, more points you will get. And of course, accuracy so important hai. So we have 40 people who have joined. We will give another 1 minute for everyone to join and we'll start by 5:16 we will start. Okay, last 10 seconds and we will get started. I think the participants are constant now. Oh, they are increasing now. We have Trojan also. We might need to exit. We get really funny names during these. Yeah. So we have someone called Chacha Ji also. Okay, I think we are getting started. I am just starting the quiz and here we go. So this is a double point question. What is the main benefit of document model over relational model? Okay. So the correct answer is you can ship the features faster, right? And I think 25 of the people have answered it correctly. So currently, let's see, Ishan is leading currently. Now, second question is, correction is corresponding to dash in relational database. I think this everyone should answer correctly. Yeah, it's a table. We still have few wrong answers, but that's correct. And let's see who is leading. Now, Harsh is leading the board now. Okay. Third question. We have few funny questions also. which some of you might like, might not like also, but yeah. What are the advantages of MongoDB over relational, right? Yeah. These are the things that we covered during the session. So the correct answer is developer agility, performance, and scalability. And again, I think 25 people have answered it correctly. Now Ravish is winning. So every question we have a leader, which is great actually. What is MongoDB Atlas? Oh, we have lot of wrong answers. It's a managed MongoDB. It's not self-managed. It's a managed service that we provide. We just discussed. I think self-managed or management confusion, okay? But it's a managed offering that we provide. Okay, now Ravish is leading. This is a multi-select question. Oh, this is not a multi-select question. I think it's given wrongly. But when was Cars 24 founded? Now this, I think we should get the names who get this wrong. Okay, so we still have 5 people who are saying 2010. But most of
कौन है वो 5 लोग कौन?
which features are supported by Atlas Data Platform? This is a multi-select, right? Some of the features we have talked about. Yes. So the correct answer is all 4, right? All these features are being supported on Atlas. We discussed search, vector search. We also have online archive where you can set up a rule to archive data. We also have charts to visualize the data. Now Deepak is leading. Atlas Search uses which open search library or engine? We discussed this multiple times today, right? So yes, Apache Lucene.
Single select, single.
Apache Lucene is what, Atlas Search is using. This is a true or false question. In ideal condition, all indexes should fit into RAM. Ideal condition. They should. In ideal condition, they should. But if they don't, that is also fine. What is the index created on arrays? We discussed this, right? On arrays, the kind of index that we create, what are those called? So those are called multi-key indexes. So 25 people have answered it correctly. And the last question is interesting, and I hope everyone gets it right? This is related to Gurgaon. What is the approximate number of liquor stores in Gurgaon? Yeah. 9 people have got it correctly. I think they should be listed somewhere.
The question was wrong. You should have asked which is the nearest one, and everyone should have said that.
Yeah, that would have been better. Okay, so let's see. So third is Ayush. Then second we have Ravish. And finally the winner is Deepak Narang. Yeah.
फोर्थ को संभावना है कि अगली बार अच्छा करो और थर्ड आओ.
But as promised, the first 3 winners do get Amazon vouchers. So Deepak, you get a Amazon voucher for 2,500 INR. Ravesh, you get it for 1,500, and Ayush, you get it for 1,000. But a round of applause for everyone for participating.
Yeah, that is all we had. Thank you. Thank you, everyone.
So just thanks to Nitin and Aril. And actually, they have taken the time out from their everyday work. And this is the additional task which I asked them to perform and come and train us. I really enjoyed the session and learned few bit. And I hope you guys have done. Please review your collections, your queries after this session and to see how we can make it better. Thank you. And thanks, Nitin and Aril.
Thank you so much. Thank you.